When we talk about database management systems and the need for databases, we invariably have to talk about digital disruption. As the smallest memory unit is called a bit. So 8-bit makes 1 byte and 1024 bytes make 1 kilobyte. So similarly, 1024 kilobytes make 1 megabyte, and then higher is gigabyte, terabyte, petabyte, exabyte, zettabyte, and then yottabyte. At the moment, the world has collected data in the zettabyte area. In 2008, Google was said to process around 20 petabytes of data a day. So that's the amount of memory that's being processed by Google. The data-driven world is always on. It allows us to track, allows us to monitor, allows us to listen, watch, and learn. So these are the attributes of memory. International Data Corporation predicts that the global data sphere will grow from 33 zettabytes, which was in 2018, to 175 zettabytes by 2025. So there's an exponential growth of memory. A key driver of this data explosion is the cloud platform or the cloud architecture. Enterprises continue to pursue cloud, both public and private, for data processing needs. There are cloud data centers, and they're becoming popular for data repositories. In 2025, International Data Corporation predicts that 49% of world's stored data will reside in public cloud environments. So the cloud interacts with various hardware like smartphones, laptop, networks, then tablets, mobile phones, servers, and so forth through network connections. And these network connections, through various middleware, they get connected to other hardware. And when enterprises collect their data, collect memory from these events that they encounter that is relevant to the enterprise, this data can be stored in the enterprise because there's so much memory or so much data that the enterprise collects relevant to the enterprise. It will collect this data, it will outsource this data into a cloud warehouse. Now, when it says a cloud warehouse, it's actually a physical infrastructure where the data is being stored. It's not a hardware. It's not on the cloud itself. It's not on a virtual platform. So the connectivity of the smart devices are the phones, televisions, thermostats, because they get connected to the cloud architecture. And they also can connect with social media, which also interacts with the cloud architecture. Social media usage in 2018, in just 1 minute, there are Twitter users sent 473,400 tweets. The Snapchat users shared 2 million photos. Instagram users posted almost 50,000 pictures. LinkedIn gained 120 new users. This is just in 1 minute. So this is the amount of new data that is being produced, or new memory that is being produced. So the Internet of Things, so also facilitating the data collecting and data sharing among various devices. Internet of Things are various devices or hardware that connects with the cloud architecture through a network connection, and this network connection will then connect with other hardware and through the cloud architecture, and then it will collect data on this Internet of Things that are connected to the cloud. For example, if you wear a watch that has internet connection or has a mobile phone that has internet connection, and wherever you go, it can detect the location and collect data about the movements. Because as you move, you carry the phone or carrying your watch with you, and it knows your location and it can collect those data. And those data, the memory of your movement, would be collected by, for example, the watch manufacturer or the mobile manufacturer, or outsourcing data company that wants to collect data. And this data could be very useful in finding out about those purchasers' movements. Database management systems can capture this data for enterprises. And because it's about memory, it's about data, analyzing this memory or the events that are collected can allow to make accurate decisions and predictions. Every enterprise tends to generate data because it engages in various events and can also buy data. There's unimaginable data quantities, and there's various data sources that an enterprise can buy. And data comes in various languages and formats. And data are structured and also unstructured. It can be well formatted, or data could be not so well formatted. So how can data help enterprises? There are 4 ways it can help. First is it can create new opportunities. It can show customer preferences and allow enterprises to make recommendations about product features to customers. It would allow to communicate through social media to preferred customers. The second is to make process improvements using data for the internal processes. The third is to get involved in data analysis. By analyzing data, the enterprises can come up with customers' dislikes and likes and offer products accordingly. And when enterprise collect data, It also can monetize this data because data has value, memory has value, and it can sell those data to another enterprise, another party, and earn money. But there are three challenges that enterprises face with this data. Data out there do not follow business rules, and it's difficult to know that they're accurate and consistent. Second is databases are designed to provide sufficient protection and partitioning and visualization data, but we need to make sure that these data are accurate and consistent. Third is databases are available and they're capable of doing various things, but there are various databases that are available. So which one is the correct database becomes a challenge for an enterprise. So in accepting data into the enterprise, invariably enterprise has to go through some control mechanisms and have some selective way of accepting data. It is done through a database engine. It creates, it reads, updates, and deletes data in the database. The business events data has a role to play in building an enterprise database. Accounting systems are built on underlying databases, and there are three aspects that are important. First are the events. There are the process data that comes into the enterprise. The second is that this data that comes into the enterprise gets stored in a database. Third, that this data that's in the enterprise has to be used up for reporting purposes. There are three functions that are conducted in data management. Master data. For the master data, that's the data that's in the enterprise, in the database, enterprise has to create new data that comes through the business events, and then also maintain those data by updating the existing data or deleting the existing data. Second are the business events. The events that enterprises encounter, like sales events, then purchasing events, leads to recording data. Third is when data are collected, they go into a database, to a master database. But in addition to that, for any contingency purposes, it must have another place where the data is kept. It's called the data warehousing. And this data warehousing is kept and used for data mining and analysis. There are events that take place in an enterprise for value creation. The events are such as sales, purchases, then human resources like recruitment. Then for each of these aspects of event, there are activities that take place. And these activities, when they are grouped together, they become processes. Or sale, order processing, and so forth for sales. And this data that comes from different processes, like order processing, then the delivery processing, and so forth, they get this data are then integrated to make a system. Each system will enable different types of enterprise decisions. So if you look at an enterprise data, it allows us to make better decisions. There are various systems using different intelligent agent software. So there's a database, and then there's a warehousing data for contingency purposes. Then there are business events taking place that updates the database and also updates the warehousing data. To support analysis of this data, enterprises use intelligent software or sets of instruction software, and these software, depending on the purpose of their use, they're called decision support systems, executive information systems, group support systems, and expert systems. So there are two ways to process event data. Transactional events are captured as accounting data. They are generalized for data capture. So the event data that's been processed, they can use an application approach for database management, or it could use a centralized approach. In the application approach in database management, applications hold this data in separate files. For example, the sales program will have the sales data, and the inventory program will lead to inventory data. In the centralized approach, the database holds all the processed data as integrated files, not as separate files, but as integrated files. For example, Oracle would hold all these as integrated files. So a graphical illustration of application approach to processing data is, if you take a sales program, it will have a sales order, then inventory, and then the customer. But each aspect of the events here, sales order, inventory, and customer, will have each master data file. And similarly, the inventory program will have the inventory order file, inventory file, and the inventory master data file. So it will have different master data files, and they are independent. Whereas the centralized approach will integrate the data captured through sales program and goes to one place, which is the data management software, and then the inventory program that captures the data of inventory will go into the data management software, and through the operating system of data management software, it will go into a database, and it will be a central database. And whenever that for reporting purposes the database is being inquired, it will now go through back again through the operating system into the database management software, and then it will use various other instructions in it to prepare reports or to make various queries that users make inquiries into the database. The application approach to database management has two disadvantages. The first disadvantage is data redundancy. That means because application approach maintains separate master data files, and there could be more than once a data field is entered into a given database. And there could be errors due to duplicate entries, more than one entry been done in different databases. There could be errors, or it could lead to frauds. And the second is different business rules would also apply to different applications. The order master data, sales order master data, would have certain business rules, and those business rules would be different from returns database, and therefore it could be incompatible. The centralized database approach, the data is being kept in separate, but still they're integrated files. That means the files can talk to each other. The way the files are talking to each other is because there are common fields or common identifiers in each of the files. And it processes data kept in relational data tables. What it means is the relation is about these common identifiers that it has in different tables. And these different tables are established through common identifiers. If I take a more kind of a straightforward approach, a common identifier in these three different integrated relational databases could be a customer identification number. But in more complex and complicated relational databases, it could be that two databases are having customer number, but second and third would have another common identifier, but which is not present in the first. So when we make a query into some data, that we have to then make a combined query. That means there are more than one common identifier if we want to tap into all three, if we want to talk into all three databases. Database management systems have a logical view and a physical view. The difference between a database and a database management system is a database is a set of tables. They're freely accessible. But database management system has forms, query, and reporting functions. Database management systems has internal controls in place. So a database management system is a more extended version or more sophisticated version of a database. Database management systems have a set of integrated programs. First is they simplify the accessing and managing the centralized database. Second, it makes the data independent of the application process approach. That means the data is not dependent on the application programs. For example, if the enterprise wants to change the add-on software on the sales events to capture sales events from Salesforce to customer relationship management software, it is still okay because the data, whatever data that's collected, is independent of those add-on software. Still, when the add-on software is changed and when data is collected, then the data, whatever that is collected, then comes to the database management system, and it will collect those data after filtering those data through the business rules and then hold those data as independent of those application approaches. Third is it can integrate files from different application approaches, because although this data that's been collected and then from different applications, sales and purchases, for example, suppliers, and then new files are created, database files are created for sales, and then purchases, new database files are created, and these files are then interconnected. They are being related to each other through common identifiers, through database management systems, software. These files still can be integrated, although the applications approaches are different for the supplier and for customers. Fourth is uses database management systems uses three-tier approaches: the presentation tier, application tier, and the database tier. So the presentation tier is the reporting tier. So it's independent of the application and the database tier. Application tier is where the data is collected from the external to the enterprise and then accepted using business logic through middleware, and that's the second tier. And the database tier is where the data is being held, and all these three are independent of each other. They are not dependent on each other. They can change independent without affecting other. And database management systems uses the software to integrate the tiers. So there are logical and physical views of data in database. The logical view is what the users wants to see from the data, how the data should be presented to the users, how the report should be prepared, how the dashboard of the data should be shown. For that purposes, data reporting software is used to come up with a set of instructions to show the data outlays, the type of data, and so forth. It's a balance sheet, income statement, cash flow, and so forth, and what items should be shown here. And then you can inquire into data through software languages like simple query languages, and ask questions from the data and get sensible answers. The second aspect is the physical view of data. The physical view of data is behind the screen, how the data is being formatted and kept in the data files. It is the schema, because data is memory. So memory has to be kept in certain order. And it should have structures, how to build meaning. And the structures or the schema is the physical view of the database. There are 5 advantages of centralized database. The first one, it eliminates data redundancy. Once the data is entered, it's entered only once into the enterprise, goes into the database file, and it sits there. It's easy to maintain data. You can delete, modify data, and it's that data, single data, piece of data that's been deleted or modified. There's data integrity because it's correct, it's more correct and holistic. For this, data are independent. You can change database without affecting applications in the database, as we previously talked about. We can change from Oracle database to SQL Oracle database, and still the data are intact. Fifth is the privacy. There's control over data access and disclosure. You can use various data encryptions and various passwords. Data could be encrypted using codes for data rather than actual data. We use a code to nominate that data, and therefore actual data is not released, but the code is released instead. Drawbacks. There are 3 drawbacks of centralized database approach. First is, if the database management system fails, it affects a greater part of the enterprise, because the central database of relational database, and then it relies for data, it relies on this database management system, and then the processing also can be affected because it cannot accept data from the process. Data is compromised, there's a larger downside risk. Therefore, the business rules or the enterprise rules in accepting, maintaining, and deleting data has to be very robust. And then the question comes up, because in a centralized database, you get data from sales, purchases, and from human resources. These data are held there. Then the question arises, who owns this data? Whether it's sales department, purchasing department, or human resources department. A solution to these drawbacks is to have continuous data protection, have contingency plan, like data warehousing, and then third is to appoint a database administrator to look after administrative and technical issues that arise. When it comes to database models, there are 4 common models. These 4 models are hierarchical, network, relational, and object-oriented. Hierarchical database model is now obsolete. It's found in legacy or old systems, good for simple data structures. The network system is also now obsolete and found in old or legacy systems. More contemporary is the relational database models. They can accommodate numbers and text as data. They're widely used. And the future is towards the object-oriented databases. They can have numbers, text, objects as data. And at the moment, they are sparsely used. If you look at the logical or the user view of database models, the hierarchical database has one parent record and one child record. For example, it would have one bank account, a customer, and one the customer would have one savings account. In the network databases, it follows the hierarchical, but then it can have more than one node. For example, the customer could have a savings account, then term deposit account, and a loan account, and so forth. So it has kind of a network, and it overcomes the problems of the hierarchy as a result. The relational database follows a more logical, organized, two-dimensional tables. It has rows, and then it has columns. Columns are to represent different fields, information fields, and then the rows are to represent different records. There can be in a sales order table. It could have different customers as records, and each customer is in a given row, and then the columns would be about the date of the sales order, the value of the sales order, whether the sales order was processed or not, and so forth. Object-oriented databases allow storing complex objects like video clips, audio clips, in addition to numbers and text, and can be performed on the objects or as attributes. So hierarchical database model is transaction data of customer. All right. For example, transaction data of recording a customer, but can't handle jointly owned accounts because customer for a single customer, there's single account, for example, in a hierarchical system, parent and child type relationship. In a network database model, it could have customer level data to start with, then have customer accounts, and then it could, under each account, there could be various transactions showing in each account. Relational database is two-dimensional collection of data, and they have a relationship, these two dimensions, and the relation between, and then in a given table they have a relationship, the columns and the rows, and then you could also have another table such as with rows and columns, and allows one table or one file to be connected, talk to the other table or other file. through a common identifier. So sales order file and the sales and the sales executed file can have, for example, customer name as a common field, and as a result, the two files can be related to each other or talk to each other through that common identifier. So to do that, there are requirements. There should be more computer memory, and there should be faster data processing time, because there's a lot of data that's now being processed because of the relationships established. So if a customer, for example, bought a laptop supplied by a supplier, and then customer also bought a chair, and supplier also supplies mobile phones and desktop computers. Here the unique identifier common to the supplier data table and customer data table is the product. Could be the laptop. So through that product, we can, the supplier database, customer database, or purchases database, and the sales database, we can connect these two databases. We can establish a relationship between these two databases using product as a common identifier, but the product should appear as a field in the supplier and also for the customer. Three elements in a relational database model is that there's more than one table in a relational database model. It could be one database data file for master data file for customers, another master data file for inventory. Then the reporting is done using across tables. When a reporting is to be done, it will use data from the customer file, it will use data from the inventory file, and then it can make a report using these two different database files. Can also query into data across tables, that is for the customers and the inventory, asking questions such as the sales quantity, sales quantity of customer, or the gross margin of customer, and so forth. I can make queries using this data. So the reports and queries are conducted using unique identifier first. These fields are included to complete the report or query, and unique identifier could be, for example, the first name and the customer. In this illustration, there's a customer data and supplier data. In both instances, we find that the first name of the customer appears, and using these two data tables, we can prepare a report inquiring into these two data tables that John bought 10,000 worth of goods supplied by Kindercorp and Raycorp, because now we are using the two databases to inquire about John's buying behavior. When data is being kept, sometimes data could be coded to de-identify and encrypt them so that a hacker gets into the database. They will find data, but they are in various coded forms that really does not make much meaning unless. So there are 5 ways of coding data. Sequential is you give a sequential number, like for a student name, we can give a student number. The second is the block codes. That means for a supplier, we give a certain codes. Products, we give another code. Third is hierarchical. A good example is the phone numbers, starting with country and service providers and the mobile number specific to the number. Mnemonics, it could have a name, course unit name like counting information systems, but the mnemonic is SAT 506 or 304 and so forth. Significant coding is where the product item is given a certain number, like Toyota is 23, Corolla is 12. Then where it is located, warehouse is given another number, and parts are given a different number. The fourth type of database model, which is the contemporary but is evolving now, is called the object-oriented database. It can store data in objects rather than in tables, and objects can be placed in hierarchy if required. The lower objects can inherit attributes from the higher objects, so that the common attributes or the so there's common identifiers between the lower and the higher objects, and it allows complex data types to be stored. For example, in object-oriented database at a workplace, you could have employee details. In that object called employee, their staff number, name and address of that employee, and then employee has a relationship with the supervisor, and then there's an object called supervisor. Supervisor's name, phone number, and address is there, and then the staff member worked in a certain branch, and then there's branch name. The object is the branch, and there's branch name, office room, where the staff member works, and the office address is also there. So these are the objects. These 3 objects here are the staff, supervisor, and branch. In each object, there's data that contains. And when a database is designed in accounting information systems, there are three categories to consider. One is the resources. The resources relates to assets, whether they are tangible or intangible. Second are the events or the occurrences, whether they are sales, purchases, or human resources. The third are the agents or the participants, are they people, enterprises, and so forth. And when an accounting system is being designed, we look at how this resource, event, and agents or the participant gets arranged. So we identify the resource, then the event, like purchase order, generating event, and then the agent. Agent could be the purchasing clerk, who is involved in processing the purchase order. And all these 3 are considered in designing an accounting system, information system. So if you look at a relationship building in REA, If you take an example, clerk is the agent that raises the purchase order, which is an event. Purchase order, which is an event, is sent to a vendor who is an agent. Vendor who is an agent send inventory, which is a resource. So all these three aspects become important. And when we design the accounting system, we can come up with this relationship between the resource and the agent and so forth. And this relationship, the business of this relationship, or the maximum number of relationships that we can have, is called the cardinality, the minimum number of relationships that we can have for each relationship, segment of the relationship is called participation. So there could be different types of relationship, one-to-one, one-to-many, many-to-many. So if you look at a relationship here in this visual, we got orders, which is an event. Then we have an agent who is a customer, and customer is placing, agent is placing orders, an event. And then because of that, there's a resource that's been used, which is inventory, and this resource is used to create another event, which is sales. And in this agent resource event relationship, there are various processes that gets connected. And in these processes, when we detail out these processes itemize these processes, there are activities, a collection of activities that take place. Databases and intelligent systems can help make good decisions. There are 9 intelligent systems: executive support systems, decision support systems, executive information systems, group support systems, expert systems, neural systems, intelligent agents, data warehouse, knowledge management systems. So let's look at one by one. Executive support systems. They're used to understand and make decisions using unstructured data. And in making such decisions under executive support systems, there's a lot of brainstorming that takes place to generate ideas. Because they are unstructured data and trying to make unstructured decisions. And because they are unstructured data, the way the decisions are made is that it's using what-if scenarios analysis. And when we talk about computers rather than humans, this kind of analysis, what-if scenario analysis, is called an ability to then come up with informed decisions, is called artificial intelligence. Decision support systems is where we use data for predictive analysis. There's data management, and there are data decision-making models. So decision support systems, executive information systems, and group support systems, they look similar, but they're slightly different. decision support systems, they analyze data and for predictive purposes. Executive information systems, they obtain data from source documents for analysis. And group support system, they analyze data using collaborative groups. Expert systems are used when higher level decisions are required. Example of these are decisions to downsize an enterprise. These decisions are extremely complex, and the experts are familiar with the implicit knowledge of this kind of complex decision making and the context in which these decisions are made. Neural networks are where computer hardware and software systems mimic the human brain's ability to recognize patterns and predict outcomes using data to come up with explicit knowledge. Intelligent agents, they are software programs that could be integrated into other software programs. Most intelligent agents are designed to learn from the actions of the system's user. And after learning, then it can make various predictions about the user's behavior. Data warehouses are we are using information systems to focus on the collecting, organizing, integrating, and long-term storing of entity-wide data. The data mining is to use data in these data warehouses to gain insights into using various multi-dimensional analytical tools and exploratory techniques. For example, using the intelligent agents and bots mentioned earlier. Knowledge management systems is the next step to database management systems. Databases store data that are turned into information by users. Knowledge refers to information that has been formatted and distributed according to organizations' standards. Effective knowledge management means the enterprise must be able to connect this data, this knowledge of individuals with other individuals in the firm who need the same knowledge. To sum up, enterprise intelligence system comprise 3 subsystems. On their own rise, they could also be called systems, but these other systems are the database management system, the ERP system or enterprise resource planning system, and thirdly, the intelligence systems.